Hello, good evening, everybody. This is student score boost project coming to you today again. Today's topic will be on calculus, and the subtopic is on limits of a function. So, with you presenting this topic is Jimo. So, this is a very important topic and is one of the basics that you need to know before you can go deeper into calculus as the limits of a function. So, to start with, I'm going to give some definition of terms that's very important in understanding this topic. So the two terms that we have here are just the limits and the function. First of all, what is a function? What is a function? A function is defined as a relation, or we can call it expression involving one or more variables. For example, I can say the age, your age, is a function of time, and I can represent the expression like this, where A is your age and T is your time. So what you see here is that you have your age being represented as a function of time. Another example, we can have a function f is a function of x and y. This is also a function of two variables. So this is just, we need to just understand this. So another important definition is limits. A limit, just as the English meaning, is a restriction on the size or the amount of something that is possible. This is just explanation, really. So we just have to put these two definitions at the back of our mind. The next is, what are the laws that are guiding limits? So that takes us to basic laws of limits. Basic laws of limits. Let's be consistent. The first one I will be talking about is the addition or subtraction law. this law says if the limits as s tends to a of a function f of x, right, and another function limit as s tends to a of g of x exist, then limit x tends to a, we can add both of them or subtract both of them and find our limits. So this is the same as limits as s tends to a of f of x plus or minus limits as s tends to a of g of x. The meaning here is that we can go from the left to the right and from the right to the left. If you have summation of f of x and the limit of both of them is the same as taking the limit of each of them and add or subtract those limits. Number 2 is limit of a constant. Limit of a constant or constant law, so to say. So in this case, we say if c is a constant and you have c as a constant and there is a function f of x which exists, then the limits as s tends to a of these constants multiplied by f of x is the same as bringing out the constants and find the limits. Okay, if you have a function and it's being multiplied by a constant c and you are finding the limit of them, it is the same as just bringing out the c, the constants, find the limit of the f of x and multiply by the constant. Another important law number 3, is the multiplication law. Multiplication law. This limit state that if the limit s tends to a of f of x and the limits s tends to a of g of x exists, then limits s tends to a of f of x multiplied by g of x, I mean this one are both together, is the same as finding the limits of them individually and multiply both of them. So if you multiply two functions that exist and you find the limit, it's the same as finding the limit of individual function and then multiply them. Another similar law is the division law. Division law, just as multiplication law, if you have f of x and g of x, and both of them has their limits possible, the limits of this function exist, then if you take the limit as s tends to 0, tends to a of f of x and g of x, both together, is the same as taking the limits individually. F x over limits as s tends to a of g of x. Number 5. Number 5 is called the power law. Power law. Supposing n is an integer and there exists a function. There exists a function f of x whose limit exists. So the limit of f of x as s tends to a and raised to power n is the same as the limit s tends to a of f of x, then everything raised to power n. Right? I hope the whole thing is clear. So with these 5 laws, we should be able to handle any question that come from the JAMB, because most of the time the question on limits in JAMB is always the simple type. For this reason, I'm going to take some example and give you some exercises. So let's look at example 1. So example 1 saying find the limits as s tends to 1 of x minus 1 over s squared minus 1. One trickish thing about limits is that you at the first instance you see them as being very simple, but if you make the mistake of just attacking it the way you say it, then you're gonna get it wrong. So let's look at this one. Score booster solution goes thus. So we want to find the limits as s tends to 1 of s minus 1 over s squared minus 1. Don't just make the mistake of saying 1 minus 1 over 1 squared minus 1 is equals to 0. This is wrong. Unfortunately, you might likely find one of the options to be 0 and you think you have got the correct answer. So what you're gonna do here, most of the time the answer of a limit will not go to 0. Take note of that. It's very rare to have 0 answer. So what you're gonna do here is, let me rewrite this. Goes to 1, x minus 1 over s squared minus 1. So what you're gonna do here is to use difference of two squares. Can you still remember that? Difference of two squares, which says if you have a squared minus b squared, this is the same thing as a plus b and a minus b. This is a common formula. So you're going to do this one, you're going to make 1 here to be squared. So you're going to have limit s tends to 1 of s minus 1 over s plus 1, then x minus 1. So looking at this now, you see that s minus 1 cancels s minus 1. So we're going to have limit s tends to 1 of 1 over x plus 1. So if you substitute the value of 1 into this, you're going to have 1 over 1 plus 1, which is 2, and this will be 0.5. As simple as that. Let me take one more example. Example 2. Example 2. The example is evaluate limit as s tends to 5 of s squared minus 4x minus 5 over x minus 5. So let's see how to work this out. I must say here that in limits, factorization is very important. You need to have some basic knowledge of factorization. So let's see the question. Limit of x tends to 0, x tends to 5, s squared minus 4x minus 5 over x minus 5. I want to say that here we need to remember how to do factorization. So in factorization, we don't have problem with the denominator. This is okay. We have problem with the numerator. So you don't just substitute 5. No, it doesn't go like that. So let's see how we can factorize it. So let's look at this one. You look at the coefficient of x here. It is 1. So now you look for factor of this minus 5, that when you multiply, okay, it's gonna give you minus 4, and when you multiply, it's gonna give you minus 5, and when you add or subtract, it's gonna give you minus 4. Let's look at it. The factor of 5 is 5 times minus 1, or minus 5 times 1. Both of this one, if you multiply, is going to give you minus 5. But which of them is going to give you minus 4? It is this one. So we're going to express this one in such a way that it's going to give us minus 4x. So you can see that if I have 5 minus 5x plus x. This will give me minus 4x. So I'm gonna substitute minus 5 plus x for this minus 4. So I will continue with my working, and I have s squared minus 5x plus x minus 5 over x minus 5. Okay, and this will be equals to limit as s tends to 5 of so we factorize now. So that is the next thing. And for you to be able to factorize, you just pair what you have here. Okay, so s, bring out s squared, you have, bring out x from s squared, you have x is left, bring out x here, you have minus 5. So I mean, what I'm indirectly saying is that look for what is common between this, and that is x. Then you factorize it. The same, what is common between x and minus 5? It's just 1. Okay, and if you bring out 1, you're gonna have plus 1. Let me just write it, and x minus 5 over x minus 5. So further simplification of this will give us x minus 5 is here, x minus 5 is here. So you can factorize s minus 5 into x plus 1 over x minus 5, right? So you see s minus 5 cancels s minus 5 here. So you're gonna have limit of x plus 1. And what is your x? Your x is 5. So now we're gonna have 5 plus 1, and that is 6. As simple as this. I hope the whole working is clear. Let me just give one more example, and to make things clear, and then give you some exercises to work with. This is an example from JAM UME 1992. The question is evaluate limits as s tends to 2 of x minus 2 bracket s squared plus 3x minus 2 over s squared minus 4. So this is what I have. So ScoreBooster solution goes thus. So what we're gonna do here is we also see how we can factorize. Let me just rewrite the question. X, let me be consistent, x minus 2, then x squared plus 3x minus 2 over s squared minus 4. This is just a repetition. So remember the difference of two squares, the one I used in my first example, this one. We're going to use the same thing. Okay, we're going to use the same thing. So here I have this. I can write this s squared minus 4 as s squared minus 2 squared. Do you agree with me? I can write this one as s squared minus 2 squared. Okay, and what will it be? It's going to be s plus 2 and x minus 2. Just this is just an explanation. Okay, so the limits now of x tends to 2, x minus 2, s squared plus 3x minus 2 over, now instead of s squared minus 4, I'm gonna write x plus 2 and x minus 2. So x minus 2 cancels s minus 2 here. So what I'm gonna have is limit s tends to 2 of s squared plus 3x minus 2 over x plus 2. At this point, you could substitute for your x and get your final answer. So I will leave the simplification for you. If you substitute, you're gonna get your answer is gonna be 2. So just try the simplification. Now with 3 examples, I hope you will be able to attack any question that come in JAM. So what I'm going to do now is to give you some exercises to work with. So exercise. So number 1, evaluate limits s tends to minus 3 of s squared minus 9 over x plus 3. So the answer will be minus 6. Let me add one more. Number 2, evaluate limits as s tends to minus 2, as s tends to minus 2 of s squared plus 6x plus 8 over x plus 2. So your answer is gonna be 2. So with this 3 practice question examples and 2 question for you to practice, we come to the end of this topic. So I wish that you don't enjoy this thing alone. Try as much as possible to share with your friends. Try to like the video and subscribe by hitting the subscribe button below the video so that you can get more video as we progress in this project. Thank you for listening and have a nice day. Thank you.